Hi everyone. So today's lesson is going to be on percent composition. This is relatively a pretty easy and short lesson. Okay, so let's move right into it. All right. What is the percent composition of water? Almost like I'm asking, what does this mean? Well, the meaning of this is this. How much of the mass of water belongs to H? And what's the percentage of the mass of water belongs to O? The question is, how do we find out? Okay, now what we do know is that H2O has a molar mass of 18 grams per mole. We got that from, hydrogen being one atomic mass. There's two of them. And oxygen have an atomic mass of 16. So I'm going to add 16 plus 1 plus 1. That's where I got the 18 from. Yeah, I like to round it to the nearest 1. All right. So out of 18 grams per mole, how much of that, what's the percentage of that belongs to hydrogen? And what's the percentage of that belongs to oxygen? All right, let's do this. So the percentage of oxygen here is that there's two hydrogen. There's two hydrogen. And each hydrogen is 1 grams per mole. And then this whole thing, which is of course water, is 18 grams per mole. Times 100. Because we're looking at percentages, right? And here in this case, that grams per mole and grams per mole will cancel. So what you really have here is a 2 divided by 18 times 100. And you're looking at 11%. Now, what is the percentage of it being oxygen? Well, you really have to calculate this if you think about it, because all percentage add up to 100. If hydrogen is 11%, I mean oxygen should be 89%, right? But let's just do it. There's one oxygen, and each oxygen is 16 grams per mole. You don't really even have to indicate that one. Out of 18 grams per mole, which is the molar mass of water. Grams per mole and grams per mole cancel. You're going to multiply this by 100. If you were to put this in your calculator, which is 16 divided by 18 times 100, you are going to get 89%. Okay. So that's how you do percent composition. It's very relatively simple. I guess the hardest part here is maybe counting the number of atoms. Sometimes maybe a little tricky, right? You might confuse yourself or something. I don't know. So let's do another example. It's not going to be that many. I promise you we'll be quick for this one. I want to know the percent composition of, let's say, calcium carbonate. Okay, so I want to know what is the percentage of it being calcium, what is the percentage of it being carbon, and what is the percentage of being oxygen. Well, before I begin, I need to know that calcium carbonate has a molar mass of 40 plus 12 plus 16 plus 16 plus 16. That is 100 grams per mole. Hey, that's pretty nice. What a nice number. All right, so let's go. How do you find percent calcium? So how much calcium is in calcium carbonate? Okay, so how much of this mass belongs to calcium, or the percentage being calcium? We'll look at mass in the next example. So calcium, there's one of them, and each calcium is worth 40 grams per mole. So it looks like this is going to be 40 over 100. Okay, so I forgot to multiply by 100. Okay, that will be 40%. Okay, meaning that the other 60% is carbon and oxygen. And let's take a look at carbon then. Carbon is, of course, 1 times 12 grams per mole over 100 times 100. So you're looking at 12%. And lastly, oxygen. You're looking at 3 oxygen. Okay, each oxygen is worth 16 grams per mole, and divide that by 100 times 100%. That will be 19, or in this case, yeah, 19%. Okay, I hope I'm doing this right. Let me just check for a bit, because no, I did something wrong. Why would it be 19? Why would it be 19? Come on, think. 48. Okay, it'll be 48. All right, so that's how you find percent composition of chemicals. So here's another question. Here's a great question, actually. Let me just delete all of this. This is so colorful. All right, if I have 16 grams of, I don't know, glucose, I could be fructose. Okay, it could also be galactose. There's many isomers of sugar that has the ratio of 1 to 2 to 1. But let's say I have 16 grams of that. I want to know, out of 16 grams, how much of it belongs to carbon, how much of that belongs to hydrogen, and how much of that 16 grams belongs to oxygen. So to do this, what you need to do is find the percent composition of C, H, and O. We know how to do that. We just did 2 examples of these things. And out of that percentages, what is 16% of that percentages? So let's check this out. This is actually not very difficult to do. So 16 grams, okay? So basically you multiply it by the percent composition, or in this case, the decimal part of it. So that will be 6 times 12, okay, divided by, okay, well, what is glucose anyways? 6 times 12 plus 12 plus 6 times 16, 180. I hope I'm right. Okay, so here it is. Okay, yeah, there you go. Okay, what would that equal to? Well, you're looking at 16 times 6 times 12 divided by 180, and that is 6.4 grams. So 16 grams of glucose, 6.4 grams of it belongs to carbon. Okay, let's do hydrogen. There's 16 grams. There are 12 hydrogen, and each hydrogen is worth 1 grams per mole out of 180. So that is 16 times 12 divided by 180. You're looking at 1.1 gram. Okay, so as you can see, even though there's a lot of hydrogen, right? There's 12 hydrogen, but hydrogen just don't weigh very much. So even with 12 of these, 16 grams, only 1.1 grams of it belongs to hydrogen. And I guess if you were to, to subtract by 16 out of the sum of this, you will find the number of oxygen. Let's say I'm going to do this by convention. So I'm going to do 16 grams times 6 times 16 over 180. Okay, so that will be, give me a second here, 8.5 grams. Okay, so yeah, here you go. Okay, this is really the same thing, but looking at mass. All right, one more examples, and then we'll call it. Okay, this is as I said, it's a very short topic, so don't need to spend that much time on it. But the next one is going to be tough. I mean, the next topic is going to be not that tough. Just follow the steps. Is that if I give you percent composition, can you give me the formula kind of thing? All right, here it is. I have 5 grams of sodium. That's not sodium. Let's use copper. Copper 2 oxide. Okay. Oh, I'm sorry. Copper 1 oxide. And I have 5 grams of copper 2 oxide. Which copper oxide has more copper? So if you're a copper miner and you're mining copper oxide, and then there's of course copper 1 oxide and there's copper 2 oxide, who gets more copper? Which miner is a better miner, getting more stuff and getting paid more? That's pretty simple. That is kind of like the question we had earlier. So let's take a look at the amount of copper you get for 5 grams of copper 2. Why would I say 2? Copper 1 oxide. So out of 5 grams of copper 1 oxide, how much of it belongs to copper? All right, so you're looking at okay, then just search for something first. I kind of forgot what is the mass of copper. I think is 64, if I remember correctly. Okay, yeah, 2 times 64. There's 2 of them, and copper is 64 grams per mole. I hope I'm right. Okay, and there's 2 of them. So let me look at my calculator. So 64 plus 64 plus 16, that is 144. Okay, so how much copper is in copper 1 oxide? All right, so that's 5 times 2 times 64. And then divided by 144. So, hey, look at that. 4.44 grams of it. So 4.44 grams of out of 5 belongs to copper. So let's do this one. So I have 5 grams. Okay. How much of that belongs to copper 2? So that would be 1 times 64. Okay, over the molar mass here will be different, obviously. It's going to be 64 plus 16, 80. And I should write grams here. Really, I shouldn't. So that will be 5 times 64 divided by 80. You're looking at 4 grams. There you go. Done. Okay. So 5 grams of copper 1. 4.44 grams of it belongs to copper. 5 grams of copper 2. 4 grams of it belongs to copper. The writing is on the wall. It's big on the wall. Copper 1 gives you more copper. Okay. So, hey, that's the power of percent composition. So that allows you to maybe make decisions in terms of if you're a miner. What do you want to mine? Anyway, that's it for today. All right. See ya.